Hi everyone, welcome to G World of Academic Physics. Today we will discuss some of the basic graph nature of electric field. Before going to this graph nature, I must introduce the electric field due to a point charge. Let's consider a point charge Q is placed here at a distance r at point P. I need to find the expression of electric field at point P due to this source charge Q, or you can say this is a point charge. What my definition said, if I want to know the expression of electric field due to a point charge, I must introduce a test charge, and whatever the influence feel by the test charge, that is nothing but the electric field intensity of this source charge or point charge. So I introduce a test charge Q naught at point P. This is positive charge, this is positive charge. There will be a Coulombic repulsion. It will be like this. And what is the expression of force? That is K Q naught upon R square. If I say this is a vector quantity, I must introduce this r cap, and this is the direction and this is the r cap direction I said. What is the definition of electric field intensity? It is defined as the force experienced by the unit positive test charge upon the test charge. So this is, if I want to write, this is Q naught upon R square R cap upon Q naught, and the result is coming KQ upon R square R cap. If I write in the magnitude form, the expression is KQ upon R square. This result has its own importance. If you look at this result, the magnitude of electric field is inversely proportional to the square of the distance between the source charge and the test charge. Can I say E is inversely proportional to R square because K constant, Q constant, only the distance varies R, so E is inversely proportional to R square. If I want to plot the graph of E versus R, this is the scenario. I want to plot the graph versus E versus R. Look at the thing here. If R tends to 0, if I put R here 0, what is the expression of electric field? Electric field value is tends to infinity. If I put R tends to infinity here, I'll get electric field tends to 0. Can I think like this? When R is 0, the electric field value is infinite, means very high. When R is infinite, the electric field value is going to 0. Can I plot the graphs like this? Yes, somehow it is from infinite. The field value will be go like this. It goes like this, and where it will come to 0? At infinite it will come to 0. Usually I have seen the students have some mistakes. They plot the graphs like this. It not touch here. Where it will touch at the infinite. So it is not touching any part of this electric field axis or not touching any part of this R axis. This is very important conclusion that someone has to be art. Second, we know for the positive charge, if you are talking about the positive charge, we know the positive charge, the field lines are radially outward. For the positive charge, the field lines are radially outward. This is the basic electric field lines properties that we have already discussed in the lecture 1. So if I draw for this positive charge, electric field versus R distance for the positive charge, what is the expressions will become? If positive charge, the field lines are radially outward. With the increase of the distance, we already know that E is inversely proportional to R square. It means the same logic will work here. When r tends to infinity, the field is coming to 0. When r is 0, this E value is maximum. So, if for the positive charge, someone has to plot, the graph nature will be like this. And where it will goes to 0? From infinity. The same symmetrical pattern one can draw the same thing here also. Yes, for the positive charge, what is the expression of electric field versus distance graph? This is electric field with distance graph, and the graph will be like this. If it will be a negative charge, one can predict what is the graph nature of the electric field. Exactly the mirror image. Exactly what? The mirror image for the positive charge. So I can plot for the negative charge, the graph nature can be, this is my negative charge, and for negative charge we know the basic property of electric field lines. The field lines are radially inward. The field lines will be radially inward. So I already said it is the mirror image of the positive charge. So for negative charge, electric field r distance, it will be a mirror image. It will be goes like this and goes like this. I hope the scenario is pretty clear. Let me discuss one more time. What we have done here, we are finding the electric field intensity due to a point charge. I placed a point charge at a distance r at point P. I need to find my expression of electric field intensity. So what I put here, a test charge, and whatever the force experienced upon this unit test charge, that is nothing but the electric field intensity of this point charge. So I write my Coulombic repulsive force with a direction, because this is a vector quantity. Upon a unit test charge, I got the expression that kq upon r square r cap. Writing the magnitude form, we concluded a very important result, that E is inversely proportional to r square. Using the properties, the basic idea is that r tends to 0, E tends to infinity. When r tends to infinity, E tends to 0. I plotted this graph, E versus r graph. And I said for the positive charge, the field lines are radially outward, and for the negative charge, the field lines are radially inward. If it is radially outward, with the increase of distance, electric field intensity inversely proportional to r square. So it will be decreased by a factor of what? R square. So the similar pattern of this graph will become here for the positive charge. If I placed here, this is a positive charge, the graph will be like this. And already we said that for the negative charge, the field lines are radially inward, so graph nature exactly the mirror image is coming for the coming of the positive charge. Let me discuss some of the other examples. Suppose this is a charge q and this is a charge q. Both are the positive charge, and someone can ask you, plot the electric field versus r, or you can say electric field versus x graph plotting. If you observe carefully, this is q, this is q. I just divided exactly at the mid. I can say this distance is r. Now the question will ask you, plot the E versus R graph. Little analysis is necessary here. If you observe, this is positive, where I will place the test charge, so that the point of equilibrium will become where the electric field is 0. This is same magnitude charge. Already in our previous lecture we have discussed, it will exactly come at the mid. The test charge will be here, where the equilibrium point will become here. It is exactly at the mid of the two charges, where the net electric field is 0. In the equilibrium point, the net electric field is 0. And we already discussed for the positive charge, what is the nature of the graph for the positive charge? I just want to plot this graph little carefully. I want to plot it. We know for positive charge the graph will be go like this, and this point the field is 0. So definitely at here it will touch and it will come here, and where it will go? It will go to infinity. And for this charge I want to plot, but where the field is 0 at this point, so it will touch here, and after that the same symmetrical pattern it will go like this. So I just draw for the charges, and I must look into the point of equilibrium where the net electric field is 0, and I have to plot like this. One more illustration I want to consider here. Suppose two unequal magnitude charges have been given here. This is Q and this is, suppose I will say 4Q. And we already know, if this will be a scenario will be like this, we already know that equilibrium point always nearest to the smaller magnitude of charge. And how to find this equilibrium point? Writing the net force of this charge and make it equalize, will get the equilibrium point. If you go through my previous lectures, you will get that equilibrium point in this case will exactly come at r by 3, and it will nearest to the smaller charge. So here if total distance is r, the equilibrium point will come at nearest to the smaller charge where the net electric field is 0. If I want to plot this graph, I know this is positive, this is also positive, and equilibrium point is here. This is my point C where this is the net electric field is 0, and I will simply draw the positive charge. What is the how to plot the positive charge? It will go like this, and here it will go like this, but where the net field is 0 at C point, it will touch the C point. For 4Q, I will draw like this, the similar positive charge it will be draw like this, and for this section if I want to draw, but it net field is at C point is 0, I just connected and it will be go like this. I hope the scenario is cleared for Q and for Q. Q and Q, if it will be similar charges, the graph tendency is like this. If it will be two different magnitude of the charges, we know that equilibrium point always nearest to the smaller charges, and it will be here Q4Q. We are plotting like this. One more illustration I want to show to my students. Little very carefully you have to be observe these things. Suppose two different polarity as well as different magnitude of the charge have been given in the questions. It means how the scenario is. Suppose this is minus Q and this is 4Q, and we know, and the question is asking find the electric field versus R graph. We already know if this kind of scenarios is given to you, we always know that equilibrium point always shifted towards the smaller charges. Here Q minus Q, here 4Q, the magnitude is here Q, smaller magnitude, so definitely equilibrium point nearest to the smaller charge. And I already said my previous lectures that equilibrium point nearest to the smaller charges, if the polarities will be different, it will lies outside, and if you go to the previous lecture, it will exactly situated at a distance r. If this distance also r, then equilibrium point will be situated here. Now the equilibrium point is here. Now I will draw the graph nature of electric fields. Little carefully, this is which charge? A negative charge. This is what? A positive charge. So I just want to draw how the graph plottings will come. Little carefully. This is positive charge. So I just make the positive charge will be like this. For the positive charge, here electric field is infinite, and where it will come to 0? When r tends to infinity, the field will come to 0. This is one important thing. And second most important thing, you have to be very carefully here. This is negative charge. So what is the graph nature for the negative charge? If someone will ask you, The graph nature for the negative charge, if someone will make here, it will be starting here and it will be starting here. But this is a negative charge, Q less magnitude, and this is what? 4Q higher magnitude. So in this case, minus Q, if I want to plot, it will be go like this. And here this it will be go like this. You have to be very carefully in these sections. Here there will be no equilibrium point, so there will be no touching in this axis. In this line there will be no touching. And little carefully, this is Q magnitude, this is 4Q magnitude. So definitely this charge impact is more, so it will cover more area. If you observe carefully here, what is happening? Here the electric field decreases. After that the electric field, what is happening? It will increases. But the impact of 4Q has greater magnitude, so this area is little more as compared to this area. Student usually not notice this kind of smaller things, but with the practice you can get the idea that this is a smaller area, this is little larger area, little like this, it's a more area. And look at this section, this is very important sections. How to plot these sections? See, at C point the equilibrium point is coming, and after that where the electric field is 0, at C point, as well as at infinite electric field is 0. When R tends to infinity, the electric field is 0. So at 2 point the electric field is 0. It means the graph nature, it will becomes like this. At 2 points the field is 0. It means it will be go like this, and it will somehow in infinity. There will be 2 points, and there are 2 points where the field is 0. So definitely one point is at infinite where the field is 0, and this is one point where the field is 0. So definitely, suppose 2 points have been given to you where the field is 0, definitely your graph will be go like this and like this. So at this 2 point the field will be 0. But if you think one point is here, another point is infinite, so definitely it will go like this, and where it will come to 0? At infinite it will come to 0 dotted like this. These are the way you have to be plot the scenarios. One more time I want to repeat. Suppose 2 points are given to you, then 2 point the electric field is 0, it will go like this, and after that this point it will be like this. But if one point is one point is here, another point is infinite, then definitely it will go like this, and after that at infinite it will be like this. The same pattern we have drawn here. If you observe this carefully, minus Q, 4Q, we know that equilibrium point will always nearest to the smaller charge, and in this case it is outside. Suppose I will say this C point, the equilibrium point. 4Q, this is a positive charge. I draw the pattern of positive charge, but little carefully the area of 4Q will be more rather than this small q, rather than this q, because this is greater magnitude, so definitely it will cover more areas. So definitely the graph tendency is little bend like this. And look at this C point. We know that equilibrium point C, the electric field is 0, as well as it is where it will be 0, at infinite it will be 0. So it will be simply goes like this at infinite. At infinite this field is going to 0, and as well as C point. So the graph will be like this. I hope this video I am giving some of the questions of graph plotting, and this will very much helpful for some of the good competitive exams. Thank you everyone. Thank you for your watching.